Hello, and welcome back to Impact Factor. I am your host, Katie Van Aken, and we are back this week with another interview episode. This week's guest is a good friend of mine from Drexel. He was in a different department than me, but we ended up collaborating on a project and writing a paper together, and he found his way into industry after grad school, and so I'm excited for you to hear our conversation. And so without further ado, here is Yuriy Smolin, PhD. All right. So I'm here with Yuriy. Yuriy Smolin was a grad student at Drexel with me, and we are actually co-authors on a paper or two. Just one?
Just one.
Just one. And I'm excited to hear what you've been up to. So welcome to the show, Yuriy.
Thanks for having me on, Katie. It's really my pleasure. I've been seeing your podcast, and I'm like, man, I really should jump on and share my story and hopefully help other people navigating the PhD and then also transitioning into industry.
Yeah. So let's start by talking about where and what you did your undergrad in.
hmm Yeah, so I got my undergrad degree in chemical engineering at the University of Virginia. And when I was there, I honestly I knew I wanted to do engineering. So when I applied, you get into kind of like a you can decide arts and sciences or engineering, and then within your first year, you have to choose what type of like engineering discipline you have to do. And for me, chemical engineering just sounded right because it's like, oh, I like chemistry. I generally was like good at math, and I found that really interesting to kind of understand the world from kind of like a mathematical standpoint. So chemical engineering is, what I ended up choosing, and I'm happy with it. But it was extremely difficult because I wasn't sure what I actually wanted to do. Like, even though I was in the engineering department, because my dad was kind of like, "Oh, you should be a doctor." Like
Mhm.
you can help people. The knowledge is like helpful. As being like a dad. So I
Is your
did
dad a doctor?
he was back in like Eastern Europe, but the degree didn't transfer over.
Gotcha. Yep.
Um, but the cool thing is that so I was chemical engineering plus I did pre-med. And
Oh.
that actually was a huge mistake because I didn't know what I wanted to do. I was like taking all these really hard chemi courses, and then on top of that, I had these like challenging, pre-med courses. And when I would take them with the other pre-med people, they were only taking like one, like or two hard classes, and I was like the hard pre-med classes plus all the chemical engineering classes. So it turned out to be a lot, and and then later, uh, in hindsight, I'm like, why did I even do pre-med? Like it really just took up so much of my time. But that's kind of like a really short story as I started into undergrad. But I can talk more if you want.
Yeah. So were you um you went straight into your PhD after undergrad, is that
hmm
right?
hmm
And what point did you decide that you wanted to continue in the education path?
Yeah, that's a great question. So honestly, grad school was not on my radar at all. My goal was like, well, engineering pays a good salary, so let me, go get a chemical engineering degree and then get a job. So my original plan was to get a job. And I think I was graduating in 2012. So it was right after that kind of like '08, '09, like, financial thing. So I had like no luck in my third year getting like any type of internship or job. So I was like, oh, this is bad. Like I need to make sure I always have something, lined up as my next step. So in my fourth year, I took an environmental engineering research position studying studying stormwater. And I found it so interesting. We would like go out to local rivers and creeks, collect the stormwater, and also learn about how water flow impacts like sedimentation and how it can erode the soil. So that was kind of my first taste at it, and I really enjoyed it. And then the professor I had, which was Professor Culver, she was like really supportive and really nice, and she was like, you really have a knack for this. Like you understand like what's going on, and kind of like it gave me a little bit in terms of like spectroscopy and stuff. So that for me was like, oh, maybe this is a nice, next step. And then I applied to like 10 different grad schools, and Drexel was like one of the grad schools I applied to because one, it had like no application fee because
Oh,
it's like $100 for every single
yep.
school, and then it's like, well, if you apply to 10, that's like $1,000, and
Yeah.
as an undergrad, that's a lot of money. But yeah, so I applied to Drexel. I applied to a couple other schools, and then I decided to go to Drexel because they had one, a good offer. Two, as I actually have a twin brother
Mm-hmm.
who went to undergrad with me, and then he also got into Drexel. So we both ended up going to Drexel together. So I thought that was a really kind of nice way to keep up, like, the twin bond.
Yeah. And he was also in chemical engineering, right?
Yeah, yeah.
Yeah.
He also studied chemical engineering. So I think in that way, we saw the world in a similar way because we both kind of were like trained as chemical engineers and is a quite rigorous uh, program. But yeah, and then once I joined Drexel, um, I kind of felt like it was a lot different than the University of Virginia. And like Drexel is a good school, and I actually think they have very strong research departments.
Yeah.
But like when I took the coursework, compared to what I was taking at UVA, I felt like Drexel was like like a weight off my shoulders.
Yeah.
So I had time to kind of like actually look into all the topics, kind of like, and I really strived. Like every single course I had, I got an A in, and I was like,
Yeah.
I'm gonna only get A's in grad school.
Which is so funny because, we start grad school as like pretty high achieving undergraduate
Hmm.
graduates, and um you soon realize that you don't it doesn't really matter if you get an A in your grad classes, like you just have to pass them.
Hmm.
um but yeah, it's interesting too that you say that you felt like the classes were manageable, because I think I've heard that from other folks too who went from, to a pretty rigorous chemical engineering program to a grad chemical engineering program, and you know it's almost like they're teaching things you've sort of already learned, and that's great, and it's like reinforcement, and that's you know and then you can kind of move on to your research, and that's really what you're there for anyway, right?
Yeah, and I think for me, the other thing I really liked about grad school is you're only taking like maybe two courses every term,
Mm,
versus in undergrad, like you probably have four or five, core engineering courses. So that gave me a lot more time to like actually digest the information, like for example, like thermodynamics or like process modeling or like solving differential equations. In undergrad, I was like, I just want to learn what I need to know so I can
yeah.
pass the test. You know.
Yes.
And I feel like in grad school the mindset is a lot different, which I really valued. It's much more like you learn this because you can actually apply it in your research,
Yeah.
so I felt like that that change in perspective really helped me like take the time to understand what I was learning, not just like, oh, I want to get an A, but like go deep. And that I think really helped me kind of understand my research better.
That's great. So what was your research in grad school?
Yeah, so actually, this is an interesting story because when so in the chemical and biological engineering department at Drexel, you select like your top three professors, and then the professors, I guess, select all their top students too. and we had like a modeling person, and he put together like a computer program that matches
Mm.
everyone to like optimize like general, like everyone gets close.
Satisfaction.
Yeah.
Yeah.
But what happened is I didn't get any of my picks. Like I might have even had four on the list, and it's like they're like, if you pick this, you kind of break the system. So you need to pick like, are you okay just taking this project? And and the project, I think no one selected it because it was a mix of modeling and experiments. So
Hmm.
my research involved depositing polymers using chemical vapor deposition techniques into energy, well, initially just into kind of solar cells. And then I kind of took that research and, worked with you, Katie, to also deposit it into supercapacitors. So it was an interesting project, but I think it was like intimidating because you had to synthesize the polymer, you had to make all the components in that solar cell, and then you had to take measurements to understand how it's working and do different spectroscopy like SEM. But on top of that, after you got your data, you need to develop like a first principles model of the solar cell to understand how is it working, how is the polymer chemistry impacting performance, and then use the model. This was always the goal, to use the model to actually predict what new chemistries, like new polymer chemistries, would be better for, if you wanted higher voltage or greater current, or just generally you wanted a better solar cell. So the research had a lot of aspects, but when Lau talked to me, he's like, "Are you interested in this? Do you care?" And I'm like, honestly, I can make anything interesting. Um,
Yeah.
and I think the PhD really taught me like you can make the project your own. It's
Mhm.
because the other interesting thing is, because I'm a twin, it gives me a good perspective. So me and Sergey had totally different projects. Mine was experimental plus modeling. Sergey did ultra fast spectroscopy to understand carrier lifetimes in like um, inorganic materials. So totally different. But we actually ended up being like you would say equally successful in terms of publishing papers, going to conferences. Like the impact factor, if you look both of us up, it's almost identical. Even though our
Yeah.
research was completely different, our advisors were completely different, and that kind of told me is as long as the project is kind of good enough, you can make it into your own, and
Yeah.
that's where I think really the PhD is, because you kind of think critically and do it your own way.
Yeah. And that's, I mean, tons of people don't even touch their research topic post grad school because it wasn't necessarily about what they researched. It was about the skills that they got from doing that research and being part of that
Mhm.
process. That's interesting. I've never actually looked up both of your impact factors and compared them, but I find that very interesting.
Yeah.
Um, so, um, what was I gonna say? Okay, so oh, and you also had to build this CVD system. Is that correct?
Yeah, so Professor Lau had, at the time, he had two reactors. One was for like ICVD, so that was like initiated chemical vapor deposition, and it really was for polymers that were deposited, that underwent like free radical polymerization. So that type of system used ICVD, which had a heated filament that initiated the initiator into a free radical, and that started the reaction. The other reactor was a OCVD, oxidative chemical vapor deposition, where the oxidizer itself was reactive enough where you didn't need a heated filament. So that's why it's O for OCVD, or O for oxidative. But yeah, the reactors were custom built, and I was kind of like the only user of the OCVD. And during the PhD, we had to move it from one lab to another lab, from the Palmisi lab into like this random lab, and I had to like take everything apart, rebuild the whole reactor. So it was a huge amount of work, and honestly, it took so long just to make like if the reaction was working in lab A, once I moved to lab B, it wasn't working. So
Yeah.
that actually took a huge amount of work just to get it where it's like, okay, the same conditions produce the same, reaction. So I guess that's something else that I learned was kind of like building stuff or troubleshooting. But I kind of think a lot of PhD students learn about like equipment maintenance or kind of optimizing your process or your equipment to get the best possible results.
Yeah. Yeah, I think I also know someone who did something similar for his lab in at Penn in Penn chemistry, and he would say that a big chunk of his PhD was kind of building or fixing or improving one of these systems. And the benefit to that is, a, you become this like subject matter expert on this system, and so anyone who wants to use that system does it with you, and then you sort of get to collaborate a lot, right? Which is what we did, right? And then the other thing is that I do think it really helps you with future life things like troubleshooting and um just fixing things, right?
Yeah, I totally agree, and actually I feel like now that I work in industry, I would say maybe like when I was a process engineer, half the job is honestly just troubleshooting processes, and a lot of the a lot of the information that I learned or like the mindset of how would you go about doing this like in a very smart and effective way, you can take that and bring it to industry. So I would definitely say that's a very valuable skill to have, not only because you're a subject matter expert on that, let's say, equipment, but just that generally how to troubleshoot processes that you build, versus like
Mhm.
partitioning experiments or, using kind of model-based problem solving and things like that.
Yeah. So let's talk about that. So you caught the research bug in undergrad, which led you to your PhD, and then were you only pursuing in industry after that?
Yeah. So, and the reason is, so there was a person in the Lao Lab before me that eventually became a professor, CMAC, who's my good friend. But he, I think it took him so long to become a professor. And then from what I heard from people, like those first 5 years that you're getting tenure is very stressful. You're constantly applying for grants. And honestly, I feel like the pay was also less than in
Yeah.
industry. So for me, I was like, from what I heard, industry is easier, so that's check. It
Hmm.
pays more, check.
Yep.
Um, and I think there's just a lot of opportunities. I think in academia, it's so competitive, and like I know Drexel has a great program as well, but I also saw like a lot of the people that became professors, like my advisors. Lau went to MIT, and then
Yeah.
from MIT he became a professor at Drexel. So I was
Yeah.
thinking, it's kind of like everyone goes almost like down a step. It's equal or down. So I was
Yeah.
thinking if I got a PhD from Drexel, then maybe it's like, I could be a professor at like Rowan or Clemson, good
Yeah.
schools, but kind of that level. And
Yeah.
and that's why I decided, well, in industry, if I'm getting paid more and it's easier,
Yeah.
maybe I should take the easy route.
So what was your first gig post Drexel?
Yeah, so this is also an interesting story. So I was like applying for jobs online, and the only job that I heard back from was Micron because I had went to a conference, the AVS conference, and I had chatted up kind of like the Micron guy, and he's like, "Oh, you did deposition in your PhD. Like, we definitely want people that have that experience." And then I remember we were in like the grad lounge and someone mentioned like, "Oh, Intel sent this solicitation to the material science department." And I'm like,
It
"What?"
might have been me, Yuri.
Oh, yeah, yeah, yeah. It might have actually been you. That's the now, like years have passed, I'm not sure,
Yeah.
but it might have been you, Katie, that like you had that information. And I remember everyone I knew applied. Like
Yeah.
Alex Crick applied, Sergey
Yep.
applied, Silas applied, Katie applied. Like everyone we knew in terms of grad school applied to Intel, and
Yep.
I think almost everyone got in.
Yeah.
Um,
Every almost everyone was offered the job, and they were seriously looking for a lot of people. So,
wait, can you repeat that? It actually cut
oh,
out, so I couldn't hear what you said.
I said, I think most people did get offered the job because they were looking to fill a lot of positions.
Yeah, yeah. And honestly, so I had the Micron offer. I had the Intel offer. The Intel offer was like, I would say like 20K more, so I'm like,
Nice.
wow, I should probably take this. And then again, going back to the twin thing, Sergey also got the offer from Intel. So we said, this is great, we still get to kind of live the twin life, live in
Yep.
Oregon, which we've never seen, and work for Intel, which is top tech company, having good salary, and kind of like enjoying life. So that's kind of, we'll say, the stage for entering Intel. And then when I entered Intel, it was actually nothing like how I thought it was going to be.
Really?
Yeah. So my team, when I joined, everyone on the team besides like three people were brand new. Like all joined within like a month or two or three. So in
Wow.
the end, we had like 20, like 15 to 20 new process engineers. And we had like three senior people. One would get sick like whenever things got hard and would just take days off. One guy didn't do anything, and then the third person left. So it really was like mostly just all these young, post grad school kids all working together. But I actually thought that made a very good team because no one knew anything, so we stayed late in the fab trying to figure out like how to run this lot through the tool so we could get like these results, and we needed to present that tomorrow morning. So definitely it was like a really fun experience, but at the same time, like I thought industry would be very like, you clock in, like almost like you clock
Yeah.
in at 8, you leave at 5, and you're kind of done. But and maybe it was my role as a process engineer at Intel, but we had on call, so
Mhm.
maybe once every 2 months or maybe once a month, you would have to be on call for a week. So during the nighttime, if someone had an issue, you would have to like wake up at an instant, get on your computer, be like calling like, what's the problem? How do we fix this? Um, so it was actually a lot more like immersive than
Yeah.
I thought industry like was. And
Mhm.
I think later maybe that was maybe more of a like Intel thing.
Yeah. Yeah, I mean they're a gigantic fab company, so um that's interesting. Did you I'm sure you feel like you learned a ton though.
Yeah. So I think the cool thing is those skills that I developed in grad school in terms of like problem solving, critical thinking, tool troubleshooting, those were the things that actually I used most of all because
Mhm.
so as a process engineer, I was in charge of the chemical mechanical planarization kind of group. So it was different than my PhD in that like you're just trying to make a wafer very flat. And it's like if you build a house, let's say a wafer or like a transistor is like a house, you need every single layer to be as flat as possible because if there's kind of some like topo, then the house is not going to sit straight, and then everything on top of it gets messed up. So the thing is like understanding how, let's say, polished chemistry impacts the removal rate or the within wafer profile, things like that. So I kind of think it was really like that problem solving and learning that the PhD kind of teaches you that I think was actually the most valuable position, or the most valuable skill set that I used
Yeah.
to for that position.
Yeah. Um so did you move it all around did you move around at all at Intel, and how long were you there for?
Yeah, so I was at Intel for almost 5 years, and then um, the first 3 years I worked as a CMP process engineer. So like I was saying, you go on call. We had a wonderful team. At the end, like after 2 or 3 years, those 20 engineers were all, really well trained. And when I was there, some of the things that were really the most meaningful to me were not even the work. Like I had started the culture team there because I kind of felt like we could improve CMP's culture. So like I led that when I was there. I also
Nice.
joined like the training and yeah, kind of like the training team, the quality team, and really it was actually those outreach kind of efforts that for me were the most meaningful. So after 3 years and kind of being like, well, what had happened is the kind of our team worked on a certain process, one of Intel's like, nodes. It was their
Yeah.
7 nanometer node. And then what happened is the higher ups had decided to go in like a different direction. So our kind of team of 20 engineers were like split and moved to different groups. And
Oh.
yeah, so it was like maybe 4 people went to this group that needed help, 4 people went to this other group that needed help. And I went to just this like random team where it was like I was starting out like from scratch again, and I'm like, I already went through this, and
Yeah.
I already have this knowledge. So um, me and actually a lot of people at that time when the group broke into parts is when people switched. And then I thought a really cool area to move into would be supply chain engineering.
Hmm.
So I moved to supply chain, and I kind of got unlucky because the reason I picked supply chain is, I would ask around at Intel like what's a easy kind of like laid back
Hmm.
area. And people kept telling me, oh, supply chain is where you go to retire. Supply chain, supply chain, supply chain.
Hmm.
So I go to supply chain thinking, okay, this is great. No more on call, kind of 8 to 5, like a regular job. But it turns out that, so I joined like the supply chain group where we were doing Intel's like next generation packaging technology. So
Okay.
it's all development because um, really the technology doesn't really exist. We're making it in real time. And then the thing is none of the materials that I was working with and the suppliers that I was working with, they were they had to qualify all this material to be able to use this process. And it turned out to be something that I felt was like all the suppliers were in Japan. So I was having meetings probably till 7, Monday, Tuesday, Wednesday, Thursday. And the amount of work that I was doing was like insane. Like that's one of the reasons I actually decided to leave Intel. But at the end, like my manager really needed to get all the results. So I would like wake up at like 3:30 a.m.,
Whoa.
work like the whole day to get like everything done. And then he would have meetings like every day at 7 till like
Yeah.
8 p.m. so I could like provide pass down. And I'm like, I'm the only one that knows this. So I gave it like everything I had, but that job gave me a good perspective because like throughout my whole PhD and also industry until that point, I felt like there was no challenge that was insurmountable. Like if let's say there's a problem, you put effort, like you directly tackle that problem and you, let's say, get rid of that stress. um but with the supply chain, it didn't work that way because one, you're working with the suppliers, so you're not actually in control. They're the one that actually has the material and is doing the tests. And then the other thing is, no matter how much effort I put in, there was always so much work.
Yeah.
Like my to-do list never went down, and I was like, and I was thinking about work all the time. So I thought, yeah, I probably should, switch into something that is a little bit more meaningful. Because I left, like I didn't have the same kind of meaningful group team that I had for my CMP role as a process engineer. So I didn't have that connection. At the same time, the work was actually way more. So it kind of like like I thought it would be something, oh, this is super easy and I'll just have an easy job. And then it turned out to
Yeah.
be, no, you got punished. Take
Yeah.
this, take this really hard project.
That's what you get for looking for an easy job.
Yeah, I learned my lesson with that one.
So yeah, so it sounds like you really didn't have any work-life balance too, because you didn't have any you didn't have a ton of time outside of work with those hours that you were keeping.
Oh yeah, yeah. I would say, and at that time, like, um, I had like recently gotten married. So I got married, and then I started this supply chain job. And honestly, like, I think at first my wife was okay with it, and then she's like, we never spent any time together. We might get 1 hour at night because she's an educator, so she would like go to sleep by 8:30. So if I'm
Yep.
finishing a meeting by 7, I'm not having dinner with her. You know, I like 1 hour a day with your spouse. I think that's like not that much.
Yeah.
And maybe some people that works fine, but I think for us it was actually a little bit more challenging. So that's one of the reasons I thought, yeah, work-life balance isn't good. It's too much work. And the other the other really weird thing is, um, Intel had this like certain way that you like they give you raises, and generally
Mm.
each salary has a certain range. And once you reach the highest end like range of that salary, the system doesn't allow you to give you a raise. And and for me, what happened is, as a process engineer, like I always tried to do my best. So I was getting like good raises. But then when I
Mhm.
switched into supply chain, I was actually above that like grade level. Like I was still the same grade, but in supply chain, the actual salaries were lower. So I
Oh,
couldn't even get a raise. And that
right.
was the other frustrating thing. It's like if I'm working all this and I don't even
Yeah.
get a raise, then what's really the point of doing this job?
Yeah. Yeah, no. I mean, those are all good reasons, and it sounds like you thought it through a lot. So then what?
Yeah. So then I switched tactics. I was like, I don't want to look for a job that's just the easiest job, because that, bit me in the butt. And I was like, I'm not gonna do this anymore. So I really tried to look for a job where I thought I would be happy, where I think I could contribute, and where it was like technically very interesting. So I looked for a while, and probably I would say, maybe 3, 4 months, I was kind of applying for jobs. And then at Lamb Research, this one opportunity came up where I think the description originally was like just process engineer 5. Okay. But in the details, it was like you have to have a love of teaching. You kind of like, create content, create like training for, internal and external customers. And, you have experience with deposition processes. And so I was like, wait, so my PhD was deposition, check.
Yeah.
You know, I have generally like semiconductor industry experience. And then when I looked back both at Drexel and Intel, the most meaningful parts of the job for me were the parts where I gave back, where I was on the training team, started these like initiatives. And at Drexel, I was the CBE GSA president, and then
Mm.
and I remember you were also the president of like, there were so many cool organizations in at Drexel, so that was one thing I really liked. But I remember we would put on like these like things to help grad students like with resumes or finding a job, and
Yeah.
um all those things that were like actually related to teaching and training. I think over time I was like, that's where I want to go because that's where I can actually help people and make a difference and make an impact. So the job was, process engineer, but really it was a kind of a technical training position where you make content for Lamb's deposition tools and like the process that is on those tools. So I kind of thought it was really cool because I was able to like use first principles, like kind of like how I learned in grad school of like understanding a process. Like there's diffusion, there's deposition, there's adsorption, there's chemical reactions. um, and then also make something, like make a training. And honestly, like since I joined, I feel like that job was really actually perfect for me. And
That's awesome. So that's where you are now?
yes, yes. And actually there's a lot of coincidences with that job because I didn't know, but I had actually applied for that job on my birthday. And
Hmm.
my ID is my birthday. So I'm kind of like I have to keep this job because it's so easy. Like it's made for me because it has my birthday as my like ID
Wow.
stuff. And yeah, yeah. So a lot of cool coincidences happened with that job.
Is that job remote,
So
or do you have to go into an office?
it was remote for like the first like 7 months, and then Lamb is like doing the kind of hybrid system. So now I go in Monday, Tuesday, Wednesday, and then I work from home Thursday, Friday. But the job is really cool because like I get to learn. So Lamb makes deposition equipment, and there's different kinds. There's like stuff related to like CVD based deposition, chemical vapor deposition, and then there's stuff based for ALD deposition, atomic layer deposition. And the really cool part about the job is I work with the technical experts to understand the processes, and they have a ton, like there's silicon dioxide deposition, there's nitride deposition, there's all different types. But I work with them to really understand the material. So one, it's like it's giving me a lot of value because I learn and I kind of understand. And then at the same time, I take all this information and I work to put together like training modules for internal and external customers. Um,
Hmm.
and for me, that's been really fun because it really is like being a content creator, similar to like
Yeah.
this podcast. Like I do all my own voice narrations. I write the script for every slide, and then they have this kind of like tool that makes it into kind of like a HTML, like kind of an interactive, almost like a little bit like a game, you know.
Cool.
So they have a lot of cool features, and it's been a great learning opportunity. And I think that's one of the reasons I like the job is I think I can just continue to learn. There's so many actually opportunities here, and I feel like I'm giving back, which was one of my things that makes me feel really committed and like fulfilled. But also, I'm constantly learning and growing too. And my manager is also like the best manager I've had. She's really supportive, but also like she's like, I trust you. You make really high quality content. Like kind of like do your best, and I think that really helps me do my best.
That's great. And work-life balance is good?
Oh, work-life balance is awesome. So I would say, I'm mostly working 8 to 5, but it's not even like I would say with this job, work-life balance is not so important because it's good. I can kind of like if let's say in a weekend I wanna like do some narration, I can do that. And then also
Yeah.
if let's say like I have to maybe like go out during lunch to get groceries or something, I think that's okay too.
Yeah.
So it's kind of like the difference is I have the option to be like flexible and um I have so much autonomy. Like
Yeah.
as long as I make high quality training and I'm, making progress on everything, I think there's no micromanagement. And I think that's what I really didn't like when I was in supply chain because I
Mhm.
would meet with that manager every Friday and we went through line item every single thing I did. And I was like, and that was
Wow.
every single week. And so he knew like, oh, you didn't make progress on this week. So like, it kind of like it makes it like a negative cycle versus I feel like when your manager gives you freedom and autonomy, it actually makes like a more positive cycle because then you can deliver better content or like higher quality results. So in the end, everyone is happy.
That's great. I love hearing people like have found a job that they love, especially if it wasn't the first place they ended up,
Hmm.
like, some of my other contacts, sort of went around from, working at a startup or working, in industry, doing research in industry or, national lab, and then sort of found their way into like business development or something, something that doesn't right off the bat feel like the right thing for a PhD, but also looking back on it now, it feels like the exact right thing for a PhD.
Yeah.
Like you are autonomous when you're a PhD student. You are teaching and learning and interacting and communicating science and technical topics a lot, and that's basically what you're now being paid to do, which is kind of awesome.
Yeah, no, I totally agree with you. And honestly, the people I worked with, at least through Intel, all had a very similar experience. I think the first job is not necessarily the ideal job. It's just like a job. You get the experience, you kind of learn about industry, and then it seems like after 3 to 5 years, a lot of people are like, okay, what do I actually want now?
Yeah.
And then they make the switch into something that's, you know, where they see value for themselves and where they see kind of value for, let's say, the company or whatever they're working on.
Yeah. Very cool. So now that you have like a decent work-life balance, have you picked up any hobbies
Oh,
or like fun things?
oh yeah, and actually, I think you might be a little surprised, but uh, I've done a ton of things. I bought a house when I started this job at Lamb. So
Cool.
so one, I feel like the job being so kind of encouraging and supportive, actually, like I actually like what Jeff Bezos says is he's like it's not a work-life balance, but it's like kind of he was saying like a work-life balance like synergy where
Mhm.
actually doing good at work empowers you for home stuff, and then kind of being your best at home also helps you be your best at work.
Yeah.
I've actually done a tremendous amount of work outside. So we have like a side yard that was like constantly getting flooded when it rains. So I completely redid it and made like this nice gravel path so it never gets flooded. I can send you some pictures, but the
Nice.
coolest thing that I've done recently is I actually built my own sauna.
Sauna.
Yeah, yeah,
Cool.
yeah, just like one person, I built like a barrel sauna that has like 2 levels, as part of like, kind of my like Zen area. So,
Mhm.
I sometimes use it like twice a week, or maybe I can use it more, but it's really relaxing, and it's a really great way for me to kind of finish off my day and like, pour some water on the hot rocks and then just kind of lay there and be like, you know.
Yeah. So, wow, so that's like self-health and health improvement. I'm blanking on the word, but um that's great, and you built it yourself. That's impressive.
Yeah, I got so they sell these like barrel sauna kits, and
Mm.
so it's kind of like prefabricated, like all the little pieces, and then I kind of have to put it together, and then but I made some kind of modifications because you're an engineer, I'm an engineer, and then like I see their directions on how to build it, and I'm like, okay, how can I make this better? So
Or
yeah,
yeah.
it was a really cool process to actually build it, and then I even put like shingles on it to protect it against water and rain.
Oh.
And actually, just like 2 days ago, there was like so much rain in Oregon, and I live behind a creek, and the creek is probably like 10 times bigger than it normally is, but the inside of the sauna was completely dry. So I'm like, looks like I succeeded in my waterproofing.
Yeah, that's great. That's great. Well, Yuri, I would like to ask you now a couple of the questions that I've been asking everyone. Um, so first, I'm going to ask you, I know it was a while ago because we are old, but what is something that was challenging during your PhD um, that you had to sort of overcome?
Mhm, mhm. I think so. I thought a lot about this question, and I feel like you can actually take the question in 2 ways. So, in terms of like technical challenges, I would say the most challenging thing for me was figuring out how to deposit polyaniline using OCVD. Because you know, because you collaborated with me on the project.
Yeah,
It had never been done before using OCVD, and my advisor, he was like, honestly, like he's like, I know the team at MIT has tried this, so like you almost like don't waste your time. So I was kind of like, but for me that was very interesting because it is so challenging. I'm like, well, if no one has done it, then that's exactly where I want to be. Um,
exactly. Yes.
so
But it's also scary and challenging because no one's done it, so you're alone, right?
yes, yes, you're alone. The other thing is I couldn't let it take away like my normal research, so I kind of would like tinker at it. Like it became like my passion project, or maybe I'll spend
Yeah.
like one day working on this just because I was
Yeah.
interested, and then the other time doing like the normal research. And the thing that was challenging was like understanding what was really going on because when I eventually got it to polymerize, there was no polymer on the stage. There was no polymer on the sample. All I noticed is there would be like a blockage that would form in the tubes in the manifold. I'm like, okay, there's a blockage, but that means
Yeah.
something is happening. And then how do I
Right.
move that blockage from, let's say, like 4 inches from the chemicals to, like a
Where
foot
you want it
away?
to be.
Yes. Yeah, yeah,
Yeah.
yes. So I would say that was technically the most challenging part. And I remember there were times I was so scared because so the chemicals I worked with were like one of them was like extremely toxic. It was antimony pentachloride, very reactive, like really bad stuff. And so I would always have them in like a little vial, and I would put the vial onto this kind of like manifold that had like vacuum pressure. And this one time, I was working in the lab, and it was like maybe like 5, so it's kind of late. And then at so normally I would kind of put tension on the vial. The top was metal and the rest was glass to kind of unsuck it from the manifold,
Yeah.
even with the pressure off. But this time
Yeah.
when I did it, the vial actually breaks,
Well,
like in the middle. And
yeah.
and I'm really worried because I'm the only one wearing a respirator, and in this whole area, no one else is wearing it. So I'm like, even though my heart is racing at like 100 beats a minute, you know,
Yeah.
I'm outside. I'm super calm, and I'm just thinking, what's the best way to do this?
Yeah.
And so I think I take a second glove, I put the glove around it, and then I just very carefully carry it to the fume hood,
Yep.
and then after that I'm like, and even in the fume hood I think like the fume hood could only handle like so much of this chemical anyway, so I had to like figure out a way to like move in and isolate it. But long story short, the polyaniline deposition was the most challenging technical aspect of my PhD, and I think just dangerous chemicals, never been done, but very rewarding.
Yeah.
um, and then I think the reason I kind of thought this question in two ways was that's like a technical challenge, but I think another big aspect of the PhD is like relationships and developing relationships with people, and kind of especially if you have like a mentor, working with them and kind of like understanding their mentorship style. And I would say that was kind of challenging for me because when I joined, there was like a senior guy that was just about to leave, and and I s- I always just like had a hard time working with him,
Yeah.
and I think he was very very smart, but he was like I don't know, so that challenge. What I did is I just kind of waited out until he graduated, and I was like,
Right.
okay, now I can move on. But I would say those type of challenges you face in industry as well. So
Yeah.
I think now I'm actually much better kind of relationship development and kind of like building those connections, because you never know when you know you might need help, or everyone only has a limited amount of knowledge no matter how much you study. So I might know one thing, you know something else, you know all the CDC carbon stuff. I know polymers, but actually working together, you can make something that, you couldn't
That's
make.
cool.
Yeah, yeah.
Yeah. Yeah, no, that's good. Yeah. I think, I mean, you're absolutely right. There's no way we can just assume that, in our whole lives we're never going to work with someone that we don't really mesh with,
Mhm.
and so learning how to get beyond that personality clash and like develop a working relationship with someone um is definitely valuable. And um it's interesting too that we're far enough out now that looking back we can say, oh, that's actually something I was bad at, and I've gotten better at it. So
Yeah, and
that's good.
I also think my current role, like from teaching, people have different styles of learning. And I kind of feel like it's the same way with kind of like interacting with people. Like
Yeah.
people have different ways. Like some people really like to, let's say, have you present next to them, let's say doing something, versus some people are like, oh, I'll send you, this is the step-by-step guide on how to do this.
Yeah.
So it's
Yep.
kind of like everyone is kind of unique in their own way. And yeah, I think that's one way where I've kind of grown a lot is I understand that maybe I have to tailor my approach to, how what the other person expects.
Yeah. Yeah, absolutely. All right, well, along those lines, if you had to give first year Yuri some advice looking back, what would that be?
Yeah. So I think uh in some ways I almost think first year Yuri was so dedicated, like I would almost tell myself like it's okay to, take a break and let's
Mm,
say like you don't have to be like the best at this. And that's where something I think I've gotten better at, and that's also like in terms of building the sauna and kind of like working on kind of house things is as I get older, I kind of see it's better to have more balance in your life. Like, for example, you have like work time where let's say you're working hard, but you also have, let's say, like rest or relaxation time. Maybe you have some exercise time, friend time, family time. So that's one thing that I think I would give my first year self advice saying you don't like just try to have the best balance in all things instead of let's say, well, I want to do a great job in the PhD. And I think we both did that, but I also think I probably would have done equally well if I had more balance because then I could have had like other things that let's say I kind of focused on. Like I know you always did your soccer coaching, and I feel
yeah.
like that was something that probably gave you like you have research, you have your soccer coaching, and all those things.
Yeah, it just gave me a break. Gave my brain a break, from thinking about research and my PhD. And I think you make a great point that having that balance actually probably makes you more successful in each of the individual areas. Um, be just like when you referenced Jeff Bezos, it's like you do well at one thing, which promotes you to do well in another thing, and it's good. That's good advice.
Yeah, actually so when I joined this technical training team, one of the things because I had like I just wanted to kind of like do stuff, I made this training on like how to have the best work-life balance slash like the most productive employees. And I basically like found tips from like Bezos, Musk, Bill Gates, like all the
Yep.
top people. And a lot of it was very, very similar. And I think it did kind of like a cornerstone of it was like one, you want balance, but two, you need to be engaged. Actually, kind of caring about what you're doing, that
Oh yeah.
motivation is what makes the difference. It's kind of like just starting the task is 90% of completing it. And I think, myself included, I have a really bad habit, honestly, of just procrastinating until the very end and then doing it all, getting it done well. But yeah, so I kind of learned a lot in that role too, and I think balance for me is something that I would tell myself.
That's great. All right, last question. Can you share with us a good memory or story from your time there? That's
Yes,
it.
yes. So this one was very easy for me, and it was going to Hawaii with everyone.
I knew you were gonna say that.
Yeah, yeah. So
Yeah.
I think for your listeners, me and you went to the ECS conference, right?
Hmm.
Electrochemical Society conference in Hawaii, and that was like the most fun trip I had ever had because I'd never been to Hawaii. We went with like it was me, you, Katie, Dillard,
Yep.
Silas, Buddha, and I think there were even a couple additional people.
Yep.
Um, but
Yeah, we
to
had a good group.
yeah, so much fun. We all learned how to surf. I still
Yep.
have the surfing pictures. My actual like swimsuit had like ripped, but I had like a swimsuit under it, so it was okay. But yeah, yeah, it was so much fun. I feel like that was like an awesome trip because at that point it wasn't even about the research. It was about just kind of having fun, enjoying the kind of atmosphere and being with good friends.
Yeah, and that was a good example of, you know, I did an episode earlier on about conferences, and one of the suggestions I have is to take advantage of a cool location that your conference is in.
Mhm.
And so, we were going there anyway, so we just extended our trip a couple days and did all of the touristy things too. Cause like, how often are you in Hawaii, So, yes, I also have that as one of my fondest memories. Um, and it was just a really good trip, really good group of people, and we made some friends there too.
Yeah, and in the PhD, I ended up, I forget, but I gave like I I added up all the conference like poster plus presentations that I had done, and it was like 20 conference presentations total. So I really enjoyed having the opportunity to travel, to go to different conferences, talk with people, form those connections. And I felt like the Electrochemical Society conference was always the best one because
Yeah.
I would go to the other ones and they'll be like, like Salt Lake City or,
Yeah.
somewhere in Texas. And the first ECS conference I went to was in Cancun. And again, I'm like, I'd never been to Cancun. I'm like, what an amazing location, like
Yep.
awesome. And then the next time they were in Hawaii, and I think that was also like all we were all fifth year, so we're all getting ready to graduate. And I'm like, this is the perfect conference to go at the end. You've pretty much done everything you need to do, and you can kind of just have fun. So yeah, it was awesome.
Yeah. It's good. It's good to have those memories. Well, Yuri, thank you so much for coming on the show. I Is there anything you wanna plug? Are you starting a podcast or writing a book or anything that we wanna advertise here?
No, not starting anything.
Okay.
Honestly, it's really just my pleasure, Katie, to, talk with you, share my experience with your audience, and hopefully there's something they can take away from it to kind of learn and grow. Yeah, but that's honestly it. I honestly just saw the opportunity and I thought like, hey, this sounds really fun and cool. And I I guess my only thing is if you ever want to have me on again, for any other topics, just let me know. I'll be happy to do it again.
Thanks to Yuri for coming on the show. If you or someone you know wants to be interviewed on Impact Factor, feel free to reach out via Instagram and follow us for updates at @ImpactFactorPod. Thank you all for listening and have a great week.